Jai Hind all of you. I am Mahima Saxena, Assistant Professor at AKGEC in CSE Department. Today's my lecture is on language model in artificial intelligence. Basically, first of all, I will explain what are the AI applications and then we will move forward towards languages. The applications are gaming, natural language processing, expert systems, and vision systems. Basically, in gaming in India, AI is utilized to be developed sophisticated mobile and online games with companies like Mobile Premier League using artificial intelligence for enhancing user engagement and improving gaming strategies. In natural language processing, if I am talking about natural language processing, startups like Haptic and Vehicular AI are harassing NLP to create assistant that understand and respond in multiple Indian language, improving customer service experiences. The next one is an expert system. AI is it's a very important part of AI. Agriculture is a major sector in India, and AI-based expert systems are being developed to help farmers with crop selection, pest control, and disease diagnosis, improving yields and sustainability. The next one is vision system. India's traffic and public safety department are using AI-driven vision system for surveillance, crowd management, and traffic control, particularly in smart city projects. The next one is speech recognition. Speech recognition is a very important factor of AI. Basically, organizations like Indian government's e-commerce services are incorporating speech recognition to help citizens interact with services in a variety of Indian languages. The next one is handwritten recognition. Bank and financial institutes in India are employing handwritten recognition technologies to process checks and form faster and more accurately. The next one is language model. Language model is basically a model in which a particular language is used. The first point is state machines. Think of these like a game of stepping stones where each stone is a state. You can move from one to another, basically a transition based on certain rules, which is called input. Examples: finite state automata, finite state transducers. In finite state automata, basically we have input and output. These are the simple state machine that follow strict rules from to move from start state to another state. Finite state transducers. These are like finite state automatas can produce output. Rule system. These are set of if-then rules. In linguistic, regular languages, context-free languages, and feature-augmented languages. In regular languages, used for simple structure like validating email formats. Context-free grammars, good for describing the structure of sentences where context isn't needed. Feature-augmented grammar. Basically, these add extra information to grammatical rules like gender or number in languages. The next one is logic. Logic models are basically precise language for computers. They help computers understand meaning and implications. Different types of logic models are: the first one is first order logic, lambda calculus, feature structure, semantic primitives. The first one is first order logic. Basically, it deals with object and their relationship. What is the relationship between an object, one object to another object, and what are the other parameters? The next one is lambda calculus, a way to express computations used in functional programming languages and semantics. The next one is feature structure, like filling out a form. Each feature like color has a value like red. The next one is semantic primitives. These are the basic concepts used to build more complex meanings. The next one is probabilistic models. Basically, these models are like weather forecast for languages, assigning probabilities to different linguistic events. Examples are: the first one is weighted automata. The second one is Markov model, and the third one is hidden Markov model. What do you mean by weighted automata? Weighted automata is basically a state machine where each transaction has a weight, like a cost or a likelihood, like some value or some input on every state is present. This is called weighted automata. The next one is Markov model. Predict a sequence of event where each event only depends on the previous one. In Markov model basically works on a sequence of events and that sequence of event completely depends on the previous sequence of events. Basically, we required input data. The next one is hidden Markov model. Like Markov model, but the states are hidden and only the outcomes are seen. The next topic is information retrieval. Information retrieval is basically a vital concept or a vital component across domain in computer science, particularly in area where large data sets are involved. Basically, we have lots of data. It may be raw data, or it may be in a tabular format data, or another format of data. We required lots of information from that data. That's why we required information retrieval concept. The first one is huge data document collection. Basically, if I am thinking about information retrieval as a vast library, just like in a physics library where books are categorized and indexed for easy retrieval, information retrieval system must manage and shift through vast amount of digital information to find what the user is looking for. The next one is format of query with standard query language. When you want to find information, you ask a question or type a search. Basically, in some system, especially database, you are a specific language. You use a specific language with a particular syntax, like SQL, structured query language, to tell the system what you are looking for. The generated result model. Basically, this is about how the system finds and pick the document that answer your query. It's like having a smart assistant in the library who understand your questions and know exactly what and where the answer are in the countless shelves of books. The next one is displaying result of model. Once your assistants find the book, they can show them to you in a different ways. Some systems just show you the titles or a brief summary, or others can give you more detailed previews. And then there are some those that might use fancy visual aids like maps or 3D models to present the information in an easy to understand manner. Basically, it's up to the agent or up to the person who are displaying the information. The next one is natural language processing. Basically, the meaning of natural language processing is a fascinating and rapidly evolving field that intersects computer science, artificial intelligence, and linguistics. Basically, NLP focuses on the interaction between computers and human languages, enable machine to understand and interrupt and generate human language in a way that is both meaningful and useful. With the increasing volume of text data generated every day, from social media posters to research articles, NLP has become an essential tool for extracting valuable insights and automating various tasks. Natural language processing is a field of computer science and a subfield of artificial intelligence that aims to make computer understand human language. Basically, NLP uses computational linguistics, which is the study of how language works, and various models based on statistics, machine learning, and deep learning. These technologies allow computer to analyze and process text or voice data to grasp their full meaning, including the speaker's or writer's intentions and emotions. NLP powers many applications that use language, such as text translation, voice recognition, text summarization, and chatbot. You may also use digital assistants, speech-to-text software, customer services bots, etc. NLP also help businesses improve their efficiency, productivity, and performance by simplifying complex tasks that involve language. The next one is techniques of NLP. The first technique is text processing and pre-processing in NLP, syntax and parsing in NLP, semantic analysis, and information extraction. The first one is text processing and pre-processing in NLP. These are the substeps like tokenization, stemming and lemmatization, stop word removal, text normalizations, etc. If I'm talking about tokenization, dividing text into smaller units such as words or sentences is called tokenization. The next one is stemming, reducing words to their base or root forms. The next one is stop word removal, removing common words like and, the, is. They may not carry any significant meaning. Because of that, we will remove these words. Text normalization, standardizing text including case normalizations, removing punctuations, and correcting spelling errors. This is called text normalization. The next one is syntax and parsing in NLP. The part of speech, dependency parsing, consistency parsing, these are the things. The first one I'll explain what is part of speech tagging. Assigning parts of speech to each word in a sentence, that is verb, noun, adjective, etc. The next one is dependency parsing, analyzing the grammatical structure of a sentence to identifying relationship between words. The next one is consistency parsing, break down a sentence into consistent parts or phrases. Example, noun phrases, verb phrases, etc. The next is semantic analysis, named entity recognition, word sense disambiguation, confidence resolution. These are the three parts of semantic analysis. The first one is named entity recognition. It basically identify and classify entities in text such as names of people, organization, locations, dates, etc. The next one is word sense disambiguation, basically determining which meaning of word is used in a given context. The next one is conference resolution, identifying when different words refer to the same entity in a text. Example, he refers to John. The next one is information extraction. Basically, entity extraction and relation extractions are the two types. The first one is entity extraction. Identify specific entity and their relationship within the text is called entity extraction. If I am talking about relation extraction, identifying and categorizing the relationship between entities in a text. The next one is language generation. Basically, in language generation, machine translation is an important point or important part. Basically, it translated text from one language to another. Text summarization, producing a concise summary of a larger text. The next one is text generation, basically automatically generating coherent and contextually relevant text. The next one is speech processing. Speech processing basically includes speech recognition and text to speech synthesis. The first is speech recognition, basically converting spoken language into a text is called speech recognition. Text to speech synthesis is converting written words into a spoken language. And the last one is question answering, retrieval based question answers and generative question answers. Basically, finding and returning the most relevant text passage in response to a query is called retrieval based questions, and generating an answer based on the information available in a text corpus is called generative question answers. The next one is dialogue systems, chatbots and virtual assistant, basically enabling system to engage in conversation with users, providing responses and performing tasks based on user input. The next is sentiment and emotions analysis in NLP. Emotion deduction is basically identifying and categorizing emotions expressed in text, like what kind of emotion someone is trying to express through writing. Opinion mining, basically analyzing opinions or reviews to understand public sentiments toward product, services, or topics. Thank you so much for today's lecture.